Well, all right, let's get started with our next subject matter expert, Christopher Van Dyke. He started Overview in 2018 to build manufacturing inspection tools with powerful algorithms and low-cost cameras from the self-driving car world. Before Overview, he worked at Tesla for nearly a decade, where he had several engineering efforts, including the design of several custom cables for electric vehicle charging. Chris, I'll turn it over to you now.
Thanks for the introduction, and thanks to the Wire Association for accepting my proposed talk and having me. As it says here, I'm going to talk about AI and computer vision and how it's enabling these new sensors that have really great characteristics and really work well for wire and cable. But before that, I just kind of wanted to go over what AI actually is. It shows up a lot in science fiction, and it has kind of a lot of casual definitions, which don't really represent the technology that I'm talking about or the way engineers talk about it. So when software engineers refer to AI, they're referring to this branch of computer vision, or sorry, computer programming, where rather than directly programming, data is used to create the functionality and the algorithms themselves. And maybe that doesn't sound that exciting, but I'm going to try to explain why it's so powerful. So to go a little deeper, AI techniques have created new ways to solve problems. Up until about 5 years ago, an engineer trying to write a program to identify a cat would have to describe what a cat was. So they might, type into their computer, if you're trying to find a cat, look for legs, 4 legs, look for fur, look for eyes, whiskers, ears. But as you can imagine, this would never work. You could never describe it correctly. There's plenty of other things that look like cats based on description. Cats in pictures sometimes don't have the things you're talking about. It's just really impossible to get it to work. However, now there are really great detectors for finding cats. And the way they work is that, or the way the engineers have done them now, is they gather thousands of images of cats and they label them as cats, and they gather thousands of images as not cats and they label those as not cats. And then they feed those into their computer program, which has a set of really complex equations. And each image sort of slowly changes those equations. And eventually you end up with this thing that can now take a new image and decide if it's a cat or not. And the engineer maybe has no idea actually what's going on in there. They couldn't ever create it themselves, but the data has allowed this thing to get created. And that's kind of why it's referred to as AI often, because it's like the computer has sort of figured out what to do based on input and not actually directly programming. So why does this matter? Well, the details don't really matter if you're just focused on the applications, but what does definitely matter is that it works really well. And it's kind of useful to recognize that it's new. I think understanding the technique can kind of highlight how this is part of a bigger technology shift. You feed in hundreds of thousands of images. Each one rewrites these incredibly complex equations. It's a ton of computation. 10 years ago, only a few research institutes had computers that were fast enough to do this. Today, computers can run these recognitions in milliseconds. You can put one of these computers at every one of your machines. You can start recognizing cats immediately. Or they're actually actual applications for wire and cable. So even before the manufacturing and wire and cable applications, just kind of more about the field in general. These techniques are clearly valuable to all kinds of engineers and entrepreneurs. Self-driving car is a very sort of easy to recognize dramatic shift. But there are also convenience stores where you can walk in and they don't have anyone working there. It's just the cameras that keep track. Alexa and Siri can understand language in these ways that's, again, so far advanced from what it was a few years ago. And your smartphone has all this technology in it. And what's kind of cool is that this industry, because it's moving fast, because people think it's powerful, it's very open with the technology. So there's a lot of resources that can help people take advantage of the new techniques. And that's one reason that a small team of ours can really make these advanced products. So kind of getting more into manufacturing, the AI-powered applications are often around autonomy, and around pattern recognition. Pattern recognition can kind of help with optimization, catching errors. AI can kind of process these tons of data and find a pattern where it's hard for a human to find a pattern. So by looking at all of the inputs across like a whole facility, you can probably find some ways to optimize set points or logistics or planning. There's also this kind of new set of AI that's showing up in robotics, where it's using both the vision and improved dexterity to do much more tricky tasks. But there are a lot of direct applications in vision by itself. And that is where you can kind of enhance awareness and recognize errors where you really couldn't before. Just like you couldn't use a camera to recognize a cat in the past, there are a lot of situations in a factory where a camera could never spot the defect or spot the error, but now they can. So when you look at how it can fit into the yeah, so believe it or not, this works especially well for wire and cable. We see the new type of computer vision as excellent for the industry. The nature of cables, the kind of slight variability, the fact that they're continuously made, the runs are long, but there are line changeovers, there's periodic errors, there's variations in shape and size. These all make it a really good fit for a deep learning system versus a traditional vision system. And you can watch the thousands of feet of cable as it's made by looking at a very small window. So you don't need a ton of cameras to really understand everything that's happening in the factory. And just like the cat recognition, we've trained our algorithms using thousands of images. You can, tens of thousands. You can see a tiny sample on the left-hand side of the screen, but this means that the same algorithm works for all different sizes of wire and all different types of wire, even different manufacturing steps. And because it's so flexible, and generally computers have gotten so inexpensive, the sensors are really easy to scale and therefore quite affordable. When thinking about how it fits into wire and cable, it can also be kind of helpful to think about the progression of quality sensors. We've been, as I've been talking about, it's sort of built off these these technologies that are shifting industries everywhere. So it is part of a progression. Just like previous sensor types, we think these will really add to the ability to make consistent and high quality cables in all kinds of facilities. And the real differentiator with these is that the newer vision techniques make the sensors way more flexible and reliable. The algorithms can learn errors and non-errors, so water droplets can be put into the pile of good images. Disturbances in lighting and motion don't cause false trips because those still end up in the pile where it's recognized as good. So these are Overview's products. The cameras are small, they come with lights integrated. They easily interface on all types of machines. There's a local computer that runs the algorithms. They're connected to the internet, which allows for excellent records and for remote access for both the users and the engineers. They work on a variety of manufacturing steps. On the left, I've got a picture on a braider. The other ones are kind of on tape or print applications, extrusion. When errors are spotted, alerts can be sent to phones or emails, stack lights can be turned on, machines can be shut down. The data is all logged for historical record. I mean, it's probably obvious, but catching errors in real time has a lot of value in reducing scrap and rework. Errors can be caught immediately, fixed before they propagate. An alert to an operator or machine shutdown, it saves the bad product being made. In the case of tape wrapping, we can actually you use the pitch change to impact the speed of the machine, so it can sort of totally operate autonomously and correct errors before they ever even make it into the finished product. Here we're taking a closer look at the print camera. So again, like cat recognition, we don't template match or use pixel math. We've labeled tens of thousands of images, and like the ones on the left, and put them into an algorithm. We mount the camera right next to the print head, and it can just immediately start looking for errors in legibility and fading or blotching, and the dropout of the print. it works for different fonts, different colors, different sizes, all the same sensor. On the right, I'm showing an error. So an alert, this would come in on a phone, or it can come in through an email, and you get to see sort of exactly what the computer picked up on. You can also just log these alerts in a database. You don't need to have the instant access, but sometimes people like the instant access. And then finally, I wanted to mention that these print cameras really help in today's operating environment with the pandemic. We can mail the cameras out and set them up remotely. We've done this in the past few months. We would rather be there to install them, but getting customers up and going with these works well. And then once they're up, they do help you run with kind of a leaner staff, or have people have more access who are working from home. And sort of on that note, because the sensors cost less, you can put them all over your factory. And once that happens, you have eyes on all your equipment. You can start to operate your factories differently. You can have different ratios of operator to machine. You can have different shift structures. The vision sensors kind of route all the information to a central location. And so everything happening on the floor sort of ends up in one spot, or in fewer spots. And that means that operators can cover a lot more ground. You can run more equipment with the same number of people. You can run equipment overnight, or on breaks, or when people are off. Machines can shut down. The sensors can shut down the machine. So even if there is a problem, you don't have anyone there to deal with it. It doesn't propagate. So the reduction in scrap and rework really make the units attractive on their own. And if you kind of use the extent, you can reduce labor and really make a step change in the operations. And Overview can help with sort of software that helps link all the stuff together to really do that. So this last slide is kind of back to the sci-fi that I was discussing at the beginning. So take it all with a grain of salt. But the computer vision watching all the machines really can open up, and understanding what's happening can open up even more automating potentials. The industry is really well suited for increased automation because machines already make all the cable. The actual turning of product into the end product is all done already through machines. So what you need is people to load and move materials around. And there are robots that are starting to affordably do this in other industries. CNC machines get loaded and unloaded. There are carts that drive wires around, or sorry, parts around. Problems where machines really work well for problems as long as they're expected. When something goes wrong that hasn't been thought through, even these really sophisticated things totally break down. So these tools are all about kind of helping good people do more, and helping well-run facilities run even better. So in summary, this is a new technology. It offers a lot of benefits. The key ones are that it costs less, and it works really well, and it's very flexible. It's highly reliable, and it can immediately help you reduce scrap and rework. So yeah, thanks for the time, and let me know if there are any questions.
I think they just unmuted me. I was saying brilliant things ahead of time. I find this fascinating. I mean, I could talk to you for hours. One question I want to ask you before we get to the other ones: how did you get into this field?
Yeah, well, so I was in manufacturing at Tesla, and was seeing the product side of computer vision in self-driving car, and Tesla also is kind of trying to push new technology into manufacturing, and so we were kind of seeing, okay, we could build tools with some of these new techniques that would really help in manufacturing, where there's so much information going around, so many problems to be solved. And then actually also at Tesla, I had designed cables. So I designed some cables for EV charging. So I had kind of somewhat of an understanding of how the cable industry worked, and what cable manufacturing was. And it just seemed like a really good fit. The technology is new and is really powerful, and it really works well in these applications. And so that's kind of why we have started here. But, we are going to use our cameras for other manufacturing steps as well, verticals as well. But we have started with wire and cable, and we've been operating here for about a year and a half.
Okay. Well, you made a good point that everything's being made by machines already. So if you can really just get the overall control by another machine, mostly these things can be automated, if you want to call it that, where people just sort of load, unload, oversee everything, and 24 hours a day, you can turn the lights off in the plant and just run.
Yeah, definitely. And what also is cool about the cameras and a lot of these things is you can add them to old machines. You don't need new machines to do all this. The vision really has a lot of ability to understand what's going on, and it can tie into a PLC and get other info that's coming off of machines. But even without that, can really understand, whether or not the cable is in good shape or not.
Okay. Well, here's a question. Are you going to be at Wire 2020 in Dusseldorf? And I guess I'd add to that, are you going to be at our Interwire show next year? Because that would be really great.
Yeah. Well, definitely. I mean, pandemic, depends kind of on what is possible in terms of travel, et cetera. But Interwire, yes, we went to the Interwire last year. We were going to go to Wire Expo. We will go to Interwire. We are US based. Dusseldorf, we haven't decided, but potentially we'll be going.
Okay. Let's see, print system. What about the twisting instability of the wire? If wire is rotating after the print head, what causes issues reading the print? I don't know if this is yours or not.
Yeah, so no, I mean, it does. Right now, we have to mount really close to the print head, so we don't have that problem. We are working on units that have more cameras that can kind of see the print coming in and out. So that is definitely a problem. We're also kind of maybe trying to figure out if there's ways to stop the rotation, but if you put it near enough to the print head, you don't have to worry about this. So it's just in situations where that's impossible, but sometimes you can move the print head or something to make it work.
Okay. The next question. I realize this technology is targeted mainly at cable makers. Could it be used for visual inspection of materials? For example, if you do visual inspection of plastic materials as a supplier to the wire and cable, can it detect defects in extruded tapes or plaques of plastics?
Yeah, the technology is flexible, and we always are looking for expanded applications. So anyone should definitely reach out to us, and we can kind of talk through the particulars. It's hard to kind of give blanket statements. Sometimes things work, quite well. The technology, like I was saying, is a little. There's an art to it in some ways, and so some stuff it seems like it'll work, and then you have a little trouble getting it to work. But most things where a human can look at it and describe the error or spot the error themselves, the machine can start to pick up on the error too. Yeah, and it really does work well where the errors and the non-errors are actually both kind of cause some signals. So you can learn the difference between the errors and the non-errors with these techniques, whereas with previous techniques that was a lot harder. So noise in non-errors often spilled over into errors.
Great. How often, if ever, are code changes necessary to sensors, and how do the upgrades, if needed, are they deployed?
Yeah, so our product is entirely connected to the internet. We have the local computer so that everything on the plant floor can operate without interruption. But we do really, the thing works way better if you have a link to the outside world where we can monitor and make sure it works, and we can push new code. And some of that is as we learn more, especially if it's a new font or something, we will upgrade the code every once in a while. But that really happens like almost invisibly to the people operating the system because of the internet connection. Same way your phone updates, things like that.
Amazing. Okay, here's a practical question. How do you prevent the camera from getting dirty?
Yeah, I mean, the camera's set back in the housing by about 6 inches and usually points down at the cable. So we haven't had it be a huge problem. But if it's a really dusty environment, there may need to be some kind of a standard operating procedure to clean it. Again, because of the flexibility and the training, it actually can deal with some of the particulate on the screen better than a traditional system can. But I mean, so far we haven't seen that as a huge problem. And worst case, maybe we'd put in some shield or something. But so far, it's been okay.
Great. Okay, can the system do multiple tasks at once with one device looking at nylon lumps and prints at the same time?
To do print and the defect detection, we do use two different systems. Long term, it's possible we'll push that into one, but it works a lot more reliably if you have one that's really focused on print and one that's focused on lumps. But you can put them right next to each other, or you can sort of fit them both in most lines.
Okay. Did you perform any projects in a wire and cable plant?
Yeah, we have several of these working in facilities with our early customers.
What type of maintenance is needed during the application? Does it need a technician with specific skills?
Because of the remote connection, like we really do the upkeep. It's meant to be very simple and not require any input or any sort of specific training on it. So yeah, we don't find that it needs a ton of like familiarity with the system before people can just start using it.
Okay. Do you know how the cameras perform in extreme temperatures, especially high heat?
That's another one that we've sort of heard about but haven't tried yet, and it is kind of general like circuit board style technology. So we think if it's up to like 50 C, it's probably fine. If it's starting to get above that, it may have either lifetime reliability issues where they just sort of like die after a year or so, or it would need some kind of an upgrade to deal with those temperatures. So we kind of like trying new things, and often we'll run a couple months at no cost if it's an application we've never done before, and we can kind of iterate on the system to get it to work. So again, definitely reach out to us if you have something in mind that seems a little out of the ordinary.
Do you need fast network connections connected to the cameras? Where is the analysis happening, on the camera or in some cloud?
Yeah, so the local computer does the algorithm recognition. The cloud connection doesn't need to be fast. We do have a live view, so if you want to open up the live stream and see what's happening, you need a fairly good internet connection, but not sort of unreasonable. Where the cloud connection is helpful is the long-term data gets stored there. So sort of the key cliffs of errors, or the just sort of number of errors that's happened. And the code we push code through that, and we kind of periodically check on it to make sure it's working. But all that is sort of asynchronous with the actual operation in the plant. The local computer can handle that. So if the internet's intermittent, the thing doesn't go down.
Are you able to talk about any payback, ROI studies that have been done in the past?
Yeah, I mean, it's so kind of like custom to people. So some cases, we have some situations where we can catch an error early in a multi-step process, and they were previously catching that at the end, the very end of the kind of building up of their whole product, and that saved a ton of rework. Um, in other times, it does kind of cut scrap, and like I was saying, washing, depends how you know how much you need your print to be exactly right, but people often do wash their print off, and so there's definite payback, but we don't have like a totally clean um sort of calculator for how to do it. We've done some stuff like that, but it tends to be very averaged out, and maybe not quite targeted at the exact application.
Are you starting to feel like you're in an interrogation?
Yeah, that should have made my slides go longer. So go ahead with your questions. It's
Okay,
okay.
here's the next one. Sorry if this question was previously asked, but what is the fastest line speed can the cable be read?
Yeah, so that is one place where there are some current limitations. Right now, it's 800 feet a minute, and it is because there's this high intensity computation going on. Um, as I've been kind of saying, we are trying to like improve things over time, and we are trying to push that up. But that's where the taping and the braiding and stuff is kind of fine. But the some of the extrusion and other ones, it works well for larger sizes, but smaller things where it's moving really fast, we haven't, it's not quite ready. But again, it's quite
Okay,
helpful if you are interested in this stuff to reach out to us, tell us what your application is, and then that can help us sort of target what to focus on next.
okay. Here's a question. Have you sent anything to Mars?
No, no,
Not yet. Okay.
we're sending, yeah.
Okay. Okay. Next question. Is there a website we can go to for more info?
Yeah, so www.overview.ai, because I should have put that on here. And then my email is chris@overview.ai. I assume
Okay.
some of this is can be found through the Wire Association as well.
Yeah. Okay. Last question. Do you plan to provide measurements with the device in the future?
Well, I guess it depends what kinds of measurements, but it is really about the recognizing the defects and not calculating diameter or things like that. That's actually quite hard for these systems to do. And lasers and stuff work well for that. So it tends to be about finding the errors. One thing that we do want to work on but doesn't exist now is where linearly in the cable did the defect happen. We can do that if we tie into if you're already measuring that in a digital way, then we can do that, and error happened 300 feet into the cable. But if you don't have that sensor already, then we don't have that. It's more about kind of spotting the error and sending the alert.
Okay. Well, good. Well, we want to thank you for a very enlightening presentation, and it was very interesting. I especially liked your cat example because I could understand that part of it for sure. And we look forward to seeing you definitely at Interwire next year, depending on obviously the situations we're all faced with. And thanks again.
All right, well, great. Thank you again for having me.